What's up, my friends? I'm David Tan, the Master Chemistry Trainer for Alchemy Adventure, and you are watching the Alchemy Adventure Learning channel, making chemistry learning a magical journey. In this video, I will share with you the fundamentals and basics required to draw a proper skeletal formula. What is a skeletal formula? A skeletal formula is a type of structural formula that serves as a shorthand representation of a molecule's bonding. In a skeletal formula, the carbon and hydrogen atoms are not explicitly shown as compared to a full display formula and where every bonds have to be shown. Therefore, a skeletal formula serves as a quick and easy way to represent the structure of a molecule. Without further ado, let's proceed to today's theme. Let's use the molecule of butane. Butane has a molecular formula of C4H10. Before we draw the skeletal formula, we need to consider or count the total number of carbon atoms that a molecule has. 1, 2, 3, 4. Therefore, there are 4 carbon atoms in the parent chain. So, we'll represent the skeletal formula in the zigzag manner. 1, 2, 3, 4. And there we have it. Notice that the carbon and hydrogen atoms are not shown. However, you need to realize that there is a carbon atom at the terminal end and it is bonded to 3 invisible hydrogen atoms. Similarly, for these 2 carbon atoms in the middle, they are actually bonded to 2 invisible hydrogen atoms that are not shown to us. Let's move on to the next example. Let's replace this hydrogen atom with a heteroatom. What is a heteroatom? A heteroatom is any atom that is neither a carbon nor a hydrogen. And if a heteroatom exists in a molecule, it has to be drawn. So let me erase this. Once again, we need to count the total number of carbon atoms. There are 4 of them. So 1, 2, 3, 4. But we add one more, chlorine over here. So this is the skeletal formula of this molecule. Let's replace Cl with OH then. Let me erase this. So how do we draw the skeletal formula of this molecule? Same thing, count the total number of carbon atoms. There are 4 of them. So 1, 2, 3, 4. But we are going to add an OH over here. Didn't I mention that hydrogen atoms are not shown explicitly? Why am I drawing hydrogen atom in this case? Well, if the hydrogen atom is bonded to a carbon atom, then it need not be shown. However, if the hydrogen atom is bonded to a heteroatom, such as oxygen in this case, then the hydrogen atom has to be drawn out. Let's consider another example. Let's replace OH with NH2, an amine molecule. So I'll redraw this again to let you have a better understanding of how a skeletal formula is drawn. Same thing, count the total number of carbon atoms. There are 4 of them. 1, 2, 3, 4. Then we add one more, NH2. The hydrogen atoms are bonded to a heteroatom, so the hydrogen atom has to be shown. Let's move to another example, which involves double bond. I will use alkene as my example. I like to keep my example simple. Let's count the total number of carbon atoms. 1, 2, 3. 3 carbon atoms. So this is how you draw a dot and cross. Our Skeletal formula. 1, 2, 3. Alright. And since the double bond lies in carbon 2 and carbon 3, we just put one more line here. Therefore, a double bond is represented by 2 parallel lines. Let's look at another example which involves a carboxylic acid. Let me erase this. So here we have a carboxylic acid. So same thing, we always count the total number of carbon atoms first. So there are 3 carbon atoms. So 1, 2, 3. Alright. Draw your parent chain in a zigzag manner. So over here we're going to add C double bond O plus an OH. So there we go. This is the skeletal formula of this carboxylic acid. Now, as mentioned earlier, the heteroatom has to be shown. In this case, our heteroatom is oxygen, so they are drawn out for us. And also, if the hydrogen atom is bonded to a heteroatom, the hydrogen atom has to be drawn out as well. Let's look at another example. Let's replace this OH with hydrogen. Right? I will erase this and draw it out again. Same thing, count the total number of carbon atoms. 1, 2, 3. And there's a C double bond O, so draw it out. And that's it. We do not draw a H over here, because as mentioned earlier, if the hydrogen atom is bonded to a carbon atom, then the hydrogen atom need not be shown. So therefore, I'll erase this. So as you can see, if you want to draw a double bond, be it a CC double bond or a C double bond O, just draw 2 parallel lines. That's all. Let's look at another example which involves a triple bond. I'll use an alkyne as an example. Let me erase this. Okay, let's change it to CH3. Alright. Similarly, okay, let me just draw this in the displayed formula first. Okay, now, so let's count the total number of carbon atoms. 1, 2, 3, 4. Therefore, 1, 2, 3, 4. And since a triple bond lies between carbon 2 and 3, we'll just replace it with 3 parallel lines. However, this is not a correct structure because we still have to look at its molecular geometry in accordance with VSEPR theory, which stands for valence shell electron pair repulsion theory. Alright, so I'll leave that discussion on VSEPR to another video, but for the purpose of discussion, I'll just tell you that we are supposed to draw this molecule this way, in a linear fashion. So this carbon atom represents carbon 4, this carbon atom represents carbon 3, this carbon atom represents carbon 2, this carbon atom represents carbon 1. So with that, I hope you have learned more about the basics and fundamentals required to draw a proper skeletal formula. Hey guys, thanks for watching this video. If you like this video, then give it a thumbs up below. If you have any question regarding this video, leave your comment below and I will respond to it. Don't forget to subscribe to my channel to get notified as soon as I upload a new video. Once again, thanks for watching and happy learning!